See, in this problem, it's given that while conducting Young's double slit experiment, a student replaced the two slits with a large opaque plate in XY plane containing two small holes. Small holes means these two, S1 and S2, are point sources, while in Young's double slit experiment, you have these slits or line sources. So, two small holes that act as two coherent point sources. So, emitting light of wavelength 600 nanometer, student mistakenly placed the screen parallel to the YZ plane. Here is the screen at a distance d equal to 3 meter from the midpoint of S1 S2 as shown in the figure. Distance between the sources is 0.6003 millimeter. So origin O is the intersection of the screen and the line joining S1 S2. Which of the following are true? Straight, bright, and dark bands. No, straight will not be formed because they are no longer slits or line sources. They are rather point sources. The region close to O will be dark, so that we have to see whether it is dark or not. So how to judge that? Say from S1 you take a light that will reach O, and from S2 you take the light which reaches O. So the path difference is equal to D. So delta x, that is delta x is equal to D. So that is delta x is equal to 0.6003 millimeter. So here the wavelength is given in nanometer, 600 nanometer. So we'll convert millimeter to nanometer. That is delta x is 0.6003 millimeter to nanometer. That is say millimeter to meter, and then again nanometer. So that means 10 to the power 6. So that means 0.6003 into 10 to the power 6 nanometer. So that is 600,300 nanometer. So that means this is 600 100 lambda plus lambda by 2, right? You see, that means delta x, path difference, is 100 lambda plus lambda by 2. So now you have this as the minima surely. So the option B is correct. The region very close to point O will be dark. And to understand that, see, it looks that this option D is correct because see the diagram. So have it like this. Say, there it is, the screen. So this screen is there. As per the diagram shown in there, actually, this is the y-axis and this is the z-axis. Okay, and here as you go, you have the two sources. See these 2 point sources S1 and S2 at a distance d. These sources are along the y-axis, and this large screen is placed along the zx plane. So you have light coming from this. So if you look at a point on the z-axis, you get a certain path difference. Sorry. And the same path difference you get along, see here, all points along this semicircle, because Below x-axis you have nothing actually. From here it is blocked. See here, you can't have anything here below this x-axis. Okay. So at this point you have a certain path difference delta x. So the same path difference you can have here delta x, because if you see the light coming from here like this, okay, and the same way you can have here also. See, so it from the symmetry of this figure, it seems that it will be semicircular. So you have dark and bright bands like this. See, this will be dark, and then you have a bright band, and then a dark band, and again bright, dark, and alternate bands of semicircular shape like this.